When there is an actual earthquake, then there is a technique called drop, cover and hold. You need to go down to a study table, just hold it and cover your head so that there should not be the head injuries which are critical and lead to the life losses. Like in today's, we just wanted to work and invest on aesthetics. So false ceiling is the common part that is there in every household. So 3 types of faults, as I mentioned. So first is the thrust fault. It has 2 categories, normal thrusting. What normal thrusting is, 2 plates are there. So they are thrusting each other but have a expansion, like one plate is there and the second plate will move like that. Then there is a reverse thrust that is there. So the compression is there, like one plate trying to push and then come upward. So that reverse thrust faulting is basically the Indian plate and the Eurasian plate. The interaction between them is like that. Indian plate is subsiding beneath the Eurasian plate at the northward direction.
Okay.
So that slip is basically leading to the accumulated energy through this friction releasing in a sudden few seconds.
Okay.
So in 30-40 seconds, that energy which has developed years or decades released in a few seconds.
So there's a lot of things we occasionally hear that people come up with all kinds of machines and all that I can predict earthquakes. So can you predict an earthquake?
So frankly speaking, no. So there are efforts that are going in place in predicting the earthquake. So what is prediction?
That can you take us through the history of earthquakes in our region and what is currently on? Because I asked this question for one primary reason. Welcome to all the viewers in the 9th episode of Risk and Resilience podcast series for Policy Perspectives Foundation. We have a very interesting guest today, a very young person and a person who in NDMA, when I worked there, this person taught me what seismology is. This person taught me what earthquake engineering is. I always thought that an earthquake is an earthquake, the ground shakes, nobody knows when it will shake, and it shakes and it kills a lot of people. But the real science behind the entire issue of seismology and what we need to do, how we need to be prepared, all that knowledge resides in this one person. There are many others, but in NDMA we had this specialist. So she is Ranu Chauhan, and she lived basically in Dehradun, Himachal, basically a girl from the hills. She did her B.Tech in civil engineering from the Pant University, and then she did her postgraduate in basically M.Tech from IIT Roorkee in earthquake engineering. And then she worked with the Disaster Management Authority in Uttarakhand, then she worked in a private concern, and then she's been with NDMA for 5 years. And she's the fulcrum on which the earthquake discussions and policy happens at NDMA. So welcome, Ranu.
Thank you.
Pleasure to have you today on the show.
Thank you for having me, sir.
Most welcome. Now we will go straight into this earthquake business. So first a question for all the common people. When an earthquake occurs, then what should we do? Suppose I'm living in a ground floor house, or suppose I'm living in a high rise. What should I do?
So like if we think from the individual perspective, so let us suppose my building is safe. Then an individual can do 2 things. The first, he or she should secure the non-structural element, which during the severe shaking of the earthquake, that may fall upon them.
What are non-structural elements?
Non-structural elements are like the parapet walls, the you can say the geysers, the almiras that you have.
Oh, these almiras where people put trophies and all that.
Exactly.
So they should be secured to the wall.
They should be secured to the wall, so that during the shaking, if the earthquake can come anytime, like you are sleeping and there is a huge painting on your head, so that may fall upon. So firstly, secure the non-structural elements. The second part, that preparedness comes in. So you should have an emergency kit in place when the earthquake is shaking. So that those are the preparedness measure. When there is an actual earthquake, then there is a technique called drop, cover and hold. You need to go down to a study table, just hold it and cover your head so that there should not be the head injuries which are critical and led to the life losses.
So those head injuries happen because of the ceiling
Falling,
and
yes.
all.
And like in today's, we just wanted to work and invest on aesthetics. So fall ceiling is the common part that is there in every household. So
false
better
ceiling is
don't
risky
go.
thing.
Yeah, better don't go with that. Or if you are going, that it should be it should be ensured that it is anchored to the roof very well.
So you're saying false ceiling is that dangerous?
Exactly.
It's the first thing to fall.
First thing to fall, because those panels that are there, so that may fall and that may fall upon you.
Okay, suppose I am wanting to make a house for myself and I live somewhere in Himachal Pradesh. So what should I look at? What should I do? How should I go about starting my house?
So let's understand like how the government system works. So there are two types of sections. First is authorized colony. So there are, every state has a building bylaws. In that bylaws, there is a chapter on structural safety, which mandate that if you are building in an authorized colony, that then you need to take up the architectural plans update, as well as you need to get the structural safety certificate. Those two things you need to submit it to the MCD, then they'll give you the approval for construction.
MCD means
municipal corporations. Okay. Of, like if we are in Delhi,
whichever
we are
city.
Talking about Delhi, and the MCDs are in all the states. So the first part is this. In the second part, where unauthorized and villages are there, so that process is not there. You just rely on the on the builders who are making the houses for you. So they don't have the technical knowledge with them. So the people should be aware. People should be aware like in which zone they are. So there are several zones. So you that awareness, that question should come up from the citizen.
So suppose I'm in a high risk zone, like Himachal is in the high risk zone. Suppose I live in the mountains. So I have an old house, I want to break it down, I want to make a new one. So what are the things I should do? I don't have any architect or anybody. I'm going to bring some stones, I'm going to bring some wood, I'm going to bring some RCC and cement. So is there some website I can see? How do I get that knowledge? That how do I make a safe structure?
So when it comes to the knowledge, so every state has developed the templates. Even NDMA has developed the homeowner guideline. So in which there is a conversation, a cartoon conversation between Dada and a granddaughter. So they are basically discussing what are the parameters that need to be looked upon. So there are several parameters. I'll highlight few. So you need to check the site specifications. So for that you need to done the geotechnical analysis of your soil to be done. Whether if you are constructing a 3-story house, suppose, so whether that load is going to be transferred through the soil. So whether that is able to take that load or not. First thing is geotechnical aspects. Then the architectural point of view. So generally for earthquake resistant design, it is recommended to go for a regular structure, for regular shape like rectangular, square. We generally go for the aesthetics like T-shapes. Those are also possible, but T-shaped buildings. Then there is a NDMC building which is of parabola type. So those structures are possible, but that need the structural intervention, non-linear analysis. But as an individual, if you are working, then go for the regular shapes. So that comes with the architecture point of view. Then third is the structural. So in the seismic related code, there are minimum clauses that are given. Like for a beam, you should have the minimum dimension of this. For a column, minimum dimension should be like this. If you're building a column, then certain minimum reinforcement should be there so that it will able to have the ductile behavior. So those minimum
column is that vertical
element
which goes through the building.
Okay. So there is a load transfer mechanism. So first the load comes to the slab. Then below the slab there is a beam. Then beam is transferring the load to the column, and then column to the foundation, and then foundation to the soil.
So wait, slab is the ceiling.
Roof or floor.
Roof.
Yeah.
And beam is the beams
runnings that are along the slab, under the slab.
Okay.
Yeah. And then columns are connected with the beams.
Okay.
Beams are transferring the load to the column. Then column is basically standing on the footing. That footing is resting on the soil.
Okay.
So that's why I mentioned the geotechnical parameter is important because ultimately load will be transferred to the foundation.
Okay.
So the third part is the structural point of view. Then it comes the non-structural that I talked earlier. Like if your structure is safe structurally, but you have the paintings, the flower pots there, the almiras are there in the room, they are not safe. And if the earthquake strikes at the night, that may cause an injury or may lead to a fatality. So the third part is the fourth part is the non-structural part that need to be taken care. These are the overall four main
So that means that for a person who's just a lay person, it is better for him to find somebody in the village who's an engineer, civil engineer, structural engineer, and first consult with that person that what should I do. So there must be some easy ways of doing all these things, not very complex. So suppose I want to buy a flat in a building in say Gurgaon, Noida. So there, what should I ask the builder?
So it's a process. Like I'll tell you, like in MCD, as per the building bylaws, they need to submit the structural safety certificate. But usually, as we had consultation with several municipal corporations, it has been seen that generally they don't ask for the structural drawings. So if you will check with the MCD, you might not get the drawings, but you can check with who's the architect who has designed that building. And then architect is in touch with the structural engineer, so you may get through a different route, but you will get the drawings. Because
so it's good to contact the architect to know whether it's structurally sound or not.
Yes. Okay. When it comes to the builder and you can ask from their office, we need the structural drawing, we need to check whether that is compliant to the prevalent disasters that are there in the region. So you can check through them.
So if there is a 20-30 storied building, what are the things that structurally need to be done, say in a place like Noida or Gurgaon? Say take Noida for example. So if let's not take Noida, let's take place in the high-risk zones in Lucknow, Kanpur, and all these areas right up to Guwahati. So all these big cities, Delhi included, they lie on the Yamuna and the Ganges. So what is the thing that the buyer should see before buying a flat?
So you've asked two questions in the one. So first one is, like you mentioned, that Noida and all the urban centers are coming up with the high-rise building of 20 stories and something. So there comes a earthquake design philosophy into play. So as you see in the Japan, what happens, they also have the skyscraper 70-story and more than that. So during the earthquake, they just sway and come back to their position. So how this is happening, that is the question. So through our Indian standards codes, they are capable enough, they are matching standards with the international standards. So in spite, there is two codes basically that need to be work upon in parallel. First is IS 1893, which help you in calculating the force that will come on the building. There is another code, IS 13920, which basically explains the detailing that need to be done for the reinforcement.
Okay.
So the buildings that are swaying, so what detailing is basically doing, it is giving your structure ability to deform. So your building can deform without any fracture or a crack.
Okay.
But the in Indian scenario, our code is giving the prescriptive design. It's like we design our building for a life safety, where we ensure that building, if there is a major earthquake, so that definition is if a magnitude of 7 more. So that can lead to a fracture. Your building will have the structural collapse, but if you have designed your building through the code, it will ensure that it will not sudden collapse.
Okay.
You will get a sufficient time to come out of your building. And your second question that is there, like you mentioned, like in the river belt, if you are constructing any house, what to see. So near the river regions, so there is a phenomena called liquefaction that is generally there. So what it did, it basically, near the river belt, so there is a soil, granular soil. So water
Granular is the same as alluvial soil.
Alluvial, granular.
Okay.
So what happened? So that the water is there already because it is near the river zone. So when there is a shaking, that induces a force that is called pore water pressure. So that reduces the capacity of your soil. So it works like a water.
So it's basically the water seeps into that.
Seeps into
beyond
the soil.
River.
Yes.
Then what happens?
Then your soil basically loses bearing capacity, and the initial parameter that I mentioned, that footing is transferring the load to the soil, and your soil is not able to take that load.
So then the buildings can tilt.
So that's why, that phenomena has been witnessed several times, like Loma Prieta earthquakes. So the whole multi-story building got tilted.
Loma Prieta.
Where was earthquake, that? I think 1995. So
in which country?
So I'm not sure about the country right now.
So this, interesting. Now please go back to Japan, Taiwan, New Zealand, and maybe the US. So what do they do for their multi-storied buildings, which prevents the cracks, prevents everything, and just sways and comes back to normal?
So as in the Indian scenario I mentioned, we go for a prescriptive design, but in other countries, they have moved a step forward in doing the performance-based design. So like what performance you are expecting from your structure. So you can't design every building to have a performance of immediate occupancy. So there are critical infrastructure that are required during the earthquake, like hospitals for treating the emergencies, and for the schools for providing the shelters. So those are the structures which need to be designed for an immediate occupancy. Like if there is a major earthquake, there are minor cracks in the structural element, your building is able to work similarly what is doing before the earthquake. Then there are residential building, as economy is also one of the part, like we allow our structure to deform. So that is the life safety. We ensure that building do not suddenly collapse. We ensure that it will give a sufficient time or take sufficient time to deform. In that duration, a person can come out and save his life. So those countries are basically investing in categorizing their buildings and ensuring there is a performance-based design for every structure.
So what are those techniques that they use? I had heard that they use things like dampers, they use base isolation. What is all that? Please explain that.
So that is the technique that has their place. So that terms are basically called as retrofitting. So retrofitting have different methods. So there are conventional method in which you strengthen the existing structure by just like if you say you have a house, you wanted to strengthen it. So if you have RCC house, then you can remove the cover, concrete cover, and tie the additional reinforcement which is needed as per the design, and then again plaster it, and that increases your column strength. Similarly, if you are masonry house means the load is transferring through the walls. There is no frame system, no column beam. The load is transferring through the frame. So there is a wire jacketing system is there. So you remove the plaster again, then a wire mesh is surrounded to whole building to ensure that your building will act as a box.
Okay, so when it shakes, the whole thing shakes.
The whole it's not that wall go.
So that is how it cracks. Okay.
So that is for the masonry structures. Then you talk about the base isolation, the damper. So that is basically what they are doing. They are these type of technologies. They are basically installing in the high priorities areas or critical facilities like hospitals. So what the damper do, what the base isolation do, they basically increase the flexibility of the foundation. So they introduce the dampers. So several type of dampers are there, lead bearing dampers. So what is the speciality of the lead?
Damper is what? Shock absorber?
Shock absorber.
A huge one.
So the shock absorber can be through a pendulum system, like your pendulum will move and dissipate the energy. Different type of material can be used, like lead is one of the material. When a force is applied, its crystals, it deforms in itself. When there is a force reversal, then it comes to the intact position.
In lead.
In lead. So So these are deformation, motion. So those are the physical things that are basically removing the energy that is
Okay, so
transferred
what you're
through the
saying is
ground.
that if the force of the earthquake takes the building this way, the pendulum or this lead thing, it takes it the other
The
way.
other way.
So it negates that movement.
Yes, reduce
Okay.
that movement.
And then there was something about rollers also. They have rollers under buildings when they make new buildings.
So that is the type of dampers that are there. So lead is there, the steel balls, that rollers are there. So the different types of damping mechanism, damping
It just
techniques
makes
are
the
there.
building move.
Moves.
Okay.
So by the movement, they are transferring or reducing or disseminating that energy which is transferring to the ground. They are not transferring that energy to the superstructure. So superstructure will not get any force. That will simply sway, and that energy is being dissipated by the dampers.
So this is a good way to do new buildings in India?
It's a good way, but that technology is not that much prevalent in India. But we can obviously have the collaboration with other countries, but there is an economic aspect also comes in, because these are the cost exhaustive technology, as well as the technical point of view. It is also important to do the analysis part,
Correctly.
non-linear analysis correctly.
So I remember in the international interactions that we had at NDMA, New Zealand and Taiwan, Japan, many of these countries, they had a system by which the builder has to certify that I am earthquake resilient, a certificate that it gets from its municipal corporation. So do you think that slowly in India we should start introducing this?
Yes, we should. Like if you ask for the architects, so there is a registration in place for them. Like if they're registered, then they can do this practice. But for the structure engineers, there is no such system. If I have obtained my B.Tech degree and I have sufficient 2 or 3 years of experience, then I can be empaneled in MCDs and I can start designing. In other countries, as you talked about US, there is a comprehensive examination that takes place, and a structure engineer need to qualify that examination, then only you can practice in the real world.
So is there any such move to do this, or you think it should be started?
It should be started. It should be started.
So I remember that the professors in IIT we used to interact with, they always had a point to make that most of the engineering students, unlike yourself, you did civil engineering, most of them don't want to do civil engineering anymore. So if you don't have civil engineers, where will you get structural engineers from? Is that a problem?
That is a problem, because everyone wants to work in a company where we get the perks, higher salaries. But generally it is seen like if we get graduate from college, so that perks are not there in civil engineering. So generally people go for computer science, where these jobs generally attract. So there is a trend in private colleges. So we have seen and heard from our colleagues that there is a trend that civil engineering candidates are being declined in the college admissions.
So which means that there can be a demand supply thing. Suppose I believe that we were working on this national earthquake risk mitigation program, in that you had designed some plans by which we could increase this demand for structural engineers. So can you, is that still around? Is that something which is doable?
So thank you for highlighting this program, National Earthquake Risk Mitigation Program. So NDMA is working on that. So yes, there is a possibility, like several engineers are working in the private organizations, and they can be tapped in because the government is coming up with the infrastructure. There is a Viksit Bharat is in place, like 2047, approximately 60% more structures need to be come up. And those need to be done through the municipal corporations. So yes, those civil engineers can be tapped or can be integrated to the municipal corporations, so that they also get the job and they also trains and hands-on on the newer buildings that are coming up.
So what you're saying is that when this new program comes up, then there will be an increase in demand for structural engineers, which is high. Engineering institutions will, the civil engineers will get more of a scope to work in.
Exactly, because program will have a certain duration, and in that duration a sufficient mitigation projects need to be taken up, retrofitting need to be taken up, technology demonstration units need to be, so who will do that? The structure engineers will do that. Similarly, SDMA will connect with those agencies and hire the civil engineering, so that
So
demands
you
will.
mentioned retrofitting. So in suppose we are here in Delhi, so what should we retrofit? We can't retrofit every building. Retrofit means that we want to make our existing building stronger.
Yes.
So which ones do we retrofit? How do you choose, prioritize?
So yes, as you mentioned, that priority need to be set up, and how you will set up the priority based on the risk that building have. So first, so we can plan in 4 manners. Like first, you can have those buildings retrofitted or doing the assessment, vulnerability assessment, those buildings which are needed during the emergency, like fire, hospitals, school buildings, EOC, or government buildings like DM office for the communications, PWDs. So those are the priorities, first priority that we can set. Then the second priority is those buildings where footfall is high, like malls are there, community centers are there, so bus stands are there, railway stations are there, those buildings are there. So we can set the second priority that. When we handled the critical infrastructures, then we come to the third priority, which are old structures. Like before, we can set a timeline, like those buildings which are constructed before 2001. So we can take up those buildings which are important, high occupancy, so those can be taken up. And the fourth priority can be those areas where the geotechnical assessments or geologically it is weak, and if your important building is there, a government infrastructure is there, so you can, on the third priority, you can take up that. So because of the limited fund, limited capacities, we need to prioritize things, as you rightly said.
Why should the government be doing all this? If there's a private building, the private guy should do it. How can government keep doing everything for everybody? People should do their own thing.
Yes, so government can't retrofitting a private house, but what government is doing, like NDMA has developed the guidelines on retrofitting, so which helps you in categorizing your building. First things, what are the technologies that are available? With minimum interventions, you can make your structure safe. So at that point of view, it is there in the guidelines.
You can do it privately also.
Yes, they can consult with the engineers, and accordingly simple measures can be taken up by the individual.
So even if somebody has constructed a house and feels he wants to get it improved, retrofitted, can go to an engineer or an architect and request him to look at the structure and assessment and then do it.
Yes,
that's possible.
Very rightly
said.
So
public should be encouraged to do that.
So that demand should come from the public.
Yeah.
So government can only handle the government buildings, and what government can do, we can demonstrate the technology, like in the village area. So you have developed the Anganwadi, and what you can do, you just paint it and mention that these are the lintel bands that can be there. Minimum 2 bars should run thoroughly through the band. So government can introduce the technology, and accordingly a homeowner
lintel
can
band
replicate.
Is what?
Lintel band is basically what the retrofitting wire mesh is doing. This is if your building is not safe, that's why you are doing the retrofitting. But initially, if you introduce the lintel band, it is a band that is running throughout your building.
Parallel to the
walls.
Okay. To the
upon
ground.
the walls.
Okay.
So like it can be at a different level. So at the roof level, it is lintel band, then sill band below the window. Then there is a foundation level, there is also a band. So in that manner, there are several bands which ensure that your masonry structure will work as a box. Your walls will not topple out or will not have out of plane and in-plane failures.
So I'll just summarize. So what you've told us is that when there is an earthquake, if you're on a higher floor, drop, cover and hold under a table.
Right.
And if you're on a lower floor like ground floor or first floor, just run out. If you can run out in 5 seconds, you can.
Yes.
Use
otherwise,
the stairs, don't use the lift.
Don't use the lift, right.
Just run out and stand in open area.
Otherwise, drop, cover and hold
drop,
is the best.
cover and hold is the best thing to do. Then you said we should keep a little kit. Kit means this where you have a torch or you have your Aadhaar card and various things like that, so that you can survive outside if there is a serious
dry
catastrophe.
snacks.
Dry snacks, okay.
Yes.
So these are the small things that normal people can do. Then when you're going to buy a house, please ask the structural engineer, are you structurally safe or not?
Yes.
And when you make a house, be very careful that you go to an engineer who understands structural engineering.
And ensure that it should be designed properly.
So we've discussed a lot about buildings and constructions. Let's move on to the actual science of seismology. So we hear that there's a lot of tectonic movements. We hear that there are a lot of tectonic plates. Then we hear there are faults. Then we hear of seismic waves. So these are three very different things. So can you explain them scientifically as to what they are?
So this is the core science that you have asked for, and it has three parts. So first I'll come on the tectonic plates. So what are these? So the whole earth is not a ball. It has several parts. So say like initially there is a core, then there is upper core, then mantle, and then there is a lithosphere, the crust layer that is there. So the crust is basically fragmented into several parts. So those parts are plates basically. So there are approximately major 15 plates, and there are some small plates are there. So you can, I'll explain you the analogy, like you can take an egg and your upper layer got fractured. So similarly there is a yolk which is liquid in form, and the cracked layer that is up there, so that is the plates, and the inner force, that is molten lava, that is giving up a force which led to a continuous motion of the tectonic plates. So your tectonic plates are continuously moving because there is a force from the internal molten part that is there. So that formulates the plate. So what is the fault line? So next question is this. So where the two plates are meeting, so that the intersection of the two plates is the fault. So there are different faults mechanism. So that depends on the movement, at what degree it moves. Accordingly, we calculate the magnitude, what energy has been released. So three types of faults as I mentioned. So first is the thrust fault. It has two categories, normal thrusting. What normal thrusting is, two plates are there. So they are thrusting each other but have a expansion, like one plate is there and the second plate will move like that. Then there is a reverse thrust that is there. So the compression is there, like one plate trying to push and then come upward. So that reverse thrust faulting is basically the Indian plate and the Eurasian plate. The interaction between them is like that. Indian plate is subsiding beneath the Eurasian plate at the northward direction. Then the third fault is strike slip. So in strike slip what happens, the plate moves parallel to each other. So that recently in Myanmar earthquake, the Sangyan fault that is there, so that is the strike slip which have movement parallel to each other and they slip. So before that I'll just, then I'll come to the waves what are there. So two types of waves are there. First are the primary waves or body waves, then the secondary waves. So let's come to how those rupture is taking place and then earthquake is generating. That earthquake is leading to the waves. So let me explain how the earthquake is happening. So what is happening under the ground? So like if we say, like if we are pushing our hands like this and try to slide, so it will sustain the energy, but at some point of time when the muscles strain is there and that exceeds that capacity, then there is a sudden slip.
Okay.
So that slip is basically leading to the accumulated energy through this friction releasing in a sudden few seconds.
Okay.
So in 30-40 seconds, that energy which has developed years or decades released in a few seconds. So that is the earthquake that has happened. So there is a vibration. So that vibration is basically traveling through the rocks because our lithosphere is a rock. So those vibrations are waves. They travel in each direction. So those two types of waves are there initially, primary wave and secondary waves. So what P wave is? P wave have the speciality, like if that travels, then particles expand or contract in that direction. Second quality of the P wave is it can travel through the rock as well as the liquid. So this, and third quality is they have the highest speed, like 5 to 8 kilometer per second. With this speed they travel. Then there is a secondary wave which has limit. There the particle motion is perpendicular. Like there is an expansion when wave is traveling. If the wave is traveling, then particle motion of secondary wave is shear, perpendicular
so
to the motion.
Primary travels like this and faster, and secondary travels like this and fast and slower.
Okay. Why they are slower? Because the secondary wave can't travel through the liquid. They can travel only through the solid part fast. So there is a molten lava that is there, that is semi-liquid. So there is a delay that they are not able to travel through that. So that's why there is a delay in the speed. So that is, S wave is approximately half of the primary wave.
Half the speed of
the primary wave. So from the combination of those two waves, there are other two waves, that is love wave and relay wave.
Love
wave and relay wave.
Raleigh wave. Okay.
So in love wave, so these two are damaging, and these two are the surface wave.
Love wave is more damaging.
Love wave is more damaging. So you can believe that.
Very interesting.
So love wave and relay wave.
Why is it called love wave?
So that is the terminology. Maybe any scientist's name. Maybe.
Okay.
So love wave and relay wave. So they are the combinations of the primary and secondary wave, like any component, vertical or horizontal component. So they basically travel along the surface, and our structure are basically on the ground. So they are more damaging to our structure.
So you're saying that the primary waves are the one that come first, secondary wave comes later, and secondary waves damage much more. They are the ones that actually cause all the damage.
Yes.
So is this where the early warning system resides?
So you have all the knowledge.
You are the one who taught me.
So yes, the early warning lies on this concept only. So initially we tap the primary wave. So there are several seismographs that are located in the country. So NCS, National Center for Seismology, is the nodal agency who is monitoring the earthquake. So they have placed the sensors in place. So when the primary wave is hitting the ground, so they are immediately tapping that window. Initially 3 seconds tap, and that transmit the signals to the data center, and from that they calculate, like after a few seconds the secondary wave may come. So that few second gap between the primary and the secondary is the lead time, which will be a warning signal can be given to the citizen for immediate equipment.
Is there this kind of an early warning system available anywhere in the world?
Yes, several countries are working on that principle. Like Japan is working. They have JMA agency, Japan Meteorological Agency is there. Then Taiwan has the system of early warning. Then US has the seismics named the early warning system. So there is early warning system in place. They are doing the two things. First, they are with the immediate tapping of the primary wave, they are just shutting down their critical or vital installations, like high speed metro rail. And then if the chemical industry is there, then immediately stop the working of that. And if there is an airport there, they transmit the signal to ATC, then it will not able to land. It will then again fly.
No landing, no takeoff.
No landing at that point of
sound.
So
this is done in Japan,
US, Taiwan, and US. So these are the three countries who are doing well.
So this is something we should look at.
So India has made efforts in that direction from very long time. Like IIT Roorkee has a dedicated department of earthquake engineering where they have worked on earthquake early warning system, and they have done the piloting in Uttarakhand state with Uttarakhand SDMA, and there is an early warning system that is there, but that is a region specific for Uttarakhand only. At the country level, we don't have the system in place, but yes, NCS is doing that efforts in that direction.
So are you including this in your earthquake mitigation program?
Yes. So the main issue is we don't have so many sensors. Currently, we have 172 sensors in place, which are very less. So we have proposed that expansion to several in 500 or thousands, so that when you have several sensors, their density is high, You like for every kilometer you have at least for every 10 or 12 kilometer square you have one sensor which can early pick up your wave and can reduce the transmission time.
So there's a lot of things we occasionally hear that people come up with all kinds of machines and all that I can predict earthquakes. So can you predict an earthquake?
So frankly speaking, no. So there are efforts that are going in place in predicting the earthquake. So what is prediction? Prediction is in advance you are telling that at this time at this location and this type of magnitude will occur. So that is generally not possible. But yes, several research is going on in that direction. So there are certain anomalies that happens when any earthquake is there. So there is a anomaly in the radon gas that is there. So electromagnetic waves changes
Radon gas in the atmosphere.
in the atmosphere.
Okay.
So animal behavior is one of the things that people tap. So few are the things that that several countries are working upon, but every earthquake has its own signature, its own origin, how it originate, what type of faulting is there. So each precursor cannot be universally applicable. So that's why we are not able to move in that direction. That's why the prediction is currently not possible.
So if we read the literature available on prediction, there was a famous prediction in the early 70s in China, and the earthquake actually happened 2 days later.
Yes.
So that was seen as a red letter day for world seismologists. So where has that gone? Like which direction is that research going? Have the Chinese got some kind of a system where prediction is possible?
So yes, they are working on, as you mentioned, that Japan had this, but that is the coincidence, because that research has not been correlated with the other earthquakes that have occurred in that area.
Okay, that same research did not predict
relate to the
earthquakes.
others.
Okay.
So yes, China is also doing like the animal behavior they are predicting, but somehow as I mentioned that research is going in that place.
But nothing concrete yet.
No.
So I remember once Professor Nishikawa from Japan had come. So I had asked him exactly this question on a podcast, and he had said no.
No.
So
Rightly
currently
said,
it is no. So
No.
the animals, his point was that animals sense the P wave, and that is why they take off. Maybe the birds take off 2 seconds, 5 seconds, 10 seconds earlier. They can sense the movement faster than the human can. So it's more of an early warning system rather than a prediction. That is what
right.
he had explained.
Exactly. And even like if there is a earthquake in oceanic region, so there is a prediction related technique that usually do in the tsunami part. Like generally when there is an earthquake, then possibility of tsunami is there when ocean water recedes. Then it will come and have tsunami.
So
that is the one part.
So the tsunami that happened, that was on the basis of an earthquake. Where did that earthquake happen?
So that is in Indo-Burma Sumatra earthquake in 2004. So that led to the tsunami as well, and that magnitude is 9.2.
Of the Sumatra earthquake.
Of the Sumatra
and that was on ground, or it was in the sea?
In the sea. So that led to the tsunami. So that has impact in the whole ocean rims. Even India, the Andaman Nicobar impacted with that.
Okay. So in the global tectonic map, where is India? Where are the main tectonic movements in the world?
So there is a ring of fire term is generally used, where it says like 75% of the earthquake activity resides there in that. So there are several countries, like Japan is also close to that. So that's why their frequency of earthquake is very high. So India is also in the one of the important plates, Indian and Eurasian. So that has the same probability of earthquake being exceeding of greater magnitude. So, but how the Indian plate risk becomes more? Why? Because of the population that is there, the exposure, the vulnerability of the buildings. So though any country is there in the ring of fire, they are exposed to the higher frequencies. But India, if there is any earthquake, because of the vulnerability that we have, so we are at the higher risk compared to other countries.
Okay, that's well explained. Now, what is the seismic zone business? How is that calibrated? Can you tell us about that? What is NDMA's role in that?
Yeah, so there is a sequence of zonation based on the knowledge that we get after every earthquake. So sequencing is there. So initially, 1934 Nepal Bihar earthquake that was there. So in 1935, Geological Survey of India has divided the country into three zones basically: high, medium, and low. So that categorization is important for understanding of the people, so that if we are coming up for any building design, so we should be clear that for what forces our building need to be constructed. So in 1962, then the Bureau of Indian Standards come up with the Indian Standard Code, which have introduced the 7 zones, 0 to 6. 0 zone is also there. Then there happened a Latur earthquake, so 1993. So that led to the engineers thinking in that direction, that initially the Deccan Plateau or the peninsular plain is considered to be safe. But then there is the Latur earthquake, which led to 8,000 casualties over there. So at that time, the Latur was in zone 1, means there is a very low risk. But after the revision that did in 2001, the 6th revision of Indian Standard Code, IS 1893, so Latur is now shifted to zone 3. So these are the zones that are there. So currently we have 4 zones. Zone 0 and 1 and 2 have been merged. So zone 2, zone 3, zone 4 and 5. So 4 zones. So why there is no 1 zone is not there, that question may come. So initially we should not have the feeling that there is no risk anywhere. So there is a low risk, but no risk concept is not there.
So is there any chance to change this? I mean, is there a need to change it? Is there any recent changes?
Yes, so the initial revisions that are there, so that is based on the deterministic approach. Like there is an earthquake, we got to know how that place is vulnerable, then we changed that part. But there is other deterministic earthquake is basically taking up the maximum scenario that can happen in any region. Like we have witnessed, we have revised our code. But there is a second concept known as probabilistic seismic hazard assessment. So what that means is we calculate the probability of occurrence of any magnitude. Like magnitude can vary from any 5 to 7, 8, 9. The probability of exceedance of any magnitude due to any fault in any time frame. So we take the probabilities of occurrences of several magnitude due to several fault lines in various return periods. So that comes with the study known as PSHA. So NDMA has made the effort in that direction. So in 2010, we did the PSHA study with the help of NEIST, CSIR NEIST. Then in 2017, DST has taken up that study, and then again in 2019, and we completed that study in 21. So we have refined that PSHA study to a small micro level assessment, which give you the probability of exceedance or PGA, peak ground acceleration, for several return periods. Then we did this study in tripartite manner with any institute, NDMA, as well as the BIS, because that study needs to be implemented or usable. So we have given that R&D part to BIS, and BIS recently in last 2-3 years have worked upon it, and recently in November 2025, so there is a gazette notification that code has been revised, Indian Standard 1893, and zones have been shifted from zone 4 to 5. So there is one addition, zone 6 addition is there. So they have basically bifurcated zone 5 into zone 5 and upper portion in zone 6. So that is there. But the another part is that zone factor is a term that is basically a factor has been assigned to every zone. So at the same time, the zone factor has also been revised for each zone. So initially, the maximum limit of zone 5 is 0.36, but now the maximum peak ground acceleration is 0.75. So almost double, you can say, or less than that. So that is the second part.
So increase in zone factor means you'll have to put in that much more cement and steel into your structures.
Rightly said,
if you're in a higher zone.
Rightly said, sir. So like these zone factors is helping into the calculation of forces, seismic forces that may come on your building. So accordingly, you need to design your building for higher forces. If you need to design your building for the higher forces, that means that additional reinforcement, additional concrete. But at the same time, as I mentioned, that there is another code, ductile detailing part is there. So if you do the enough detailing, that does not mean that your cost is increased so much as forces is increased. Generally, there is a perception like that. So the things are not like that. And whatever efforts the NDMA has made, that has resulted into the, but currently there is a stay and that notification has been taken out with the suggestion that have the wider consultation. So that is currently in place.
So this BIS code is currently under revision. It's being looked at again.
Yes, sir.
Okay, very interesting. So in all these questions, we looked at buildings, we looked at how the earth moves underneath, and we've looked at all this. So just one final question.
Yes.
That can you take us through the history of earthquakes in our region and what is currently on? Because I asked this question for one primary reason. Because I have always heard that people say that the big one is yet to hit India. So what is the assessment behind saying the big one is yet to hit? So can you take us through the archival history of earthquakes?
Yes.
And then tell us what is the possibility of a big one hitting in India?
So the main reason of the earthquake is because of the two plates, Indian and Eurasian, and they are continuously moving. That means stress is building upon, and that stress may release any time. So that's why there is a saying that big one can come any time. And when we say that there is a seismic gap, how that is related with that India already have the history of the great earthquakes. What great means? If the magnitude is greater than 8. So if the energy released is several times of magnitude 8, that means the great earthquake. So there is a history like 1819, there is a Kutch earthquake that is there. So that is
1819 is 200 years ago.
Yes, Kutch earthquake.
Okay.
So then there is a 1897 Shillong earthquake that is there. That is 8.6. Then there is a Kangra earthquake, 1905 Kangra, which led to heavy human loss and infrastructure loss. 1905. Then there is a 1934 Nepal Bihar earthquake. Then there is a 1950 Assam earthquake. So these 5 earthquakes are basically the great earthquake.
The really big ones.
Really big ones of
since
magnitude.
1950 we haven't had a really big one.
Really big one of more than 8. But yes, there are major earthquakes that are there. So that has like Latur is there 1993, Chamoli is there, Uttar Kashi is there 1991, Chamoli 1999, then Bhuj is there. So 2001, 26 January.
2015 Nepal.
2015 Nepal, 2011 Sikkim is there. So the recent one, which we can say in the Himalayan frontal thrust, is 2015. So it's been a decade. So there is there is a seismic gap and there is a possibility. But we don't need to fear for that because we have the technologies in place. We can build our resilient infrastructure for that.
So it is said that the further away you are from an earthquake, the closer you are to the next one. And alternatively, there have been 300-year gaps. So it's possible to have. So the whole thing is that the science of prediction is not very well developed.
That's
Unless that is done, you need not really worry. But still, you should be careful.
Yeah, we should be prepared.
That's the general message I get.
Yes.
And thank you so much. This was an excellent conversation.
Thank you, sir.
It has allowed me to revise all my seismology. And I shall attempt to do a multiple choice exam when you set a paper for us. So thank you so much and all
Thank
the
you.
best to you.
Thank you so much, sir. My pleasure.
Thank you.
Thank you.